Top 25 technical questions for an electrical engineer interview questions and answers. Preparing for an electrical engineering interview requires a solid grasp of core concepts, practical applications, and problem-solving techniques. Whether you're a recent graduate or an experienced engineer, understanding the types of technical questions interviewers ask can boost your confidence. Here are the top 25 technical interview questions with precise, informative answers. 1. What is the difference between a generator and a motor? A generator converts mechanical energy into electrical energy, while a motor does the opposite, converting electrical energy into mechanical energy. Generators rely on electromagnetic induction to induce voltage as conductors move through a magnetic field. Motors utilize electrical current flowing through coils within a magnetic field to create rotational force. In essence, the generator is a power source, and the motor is a power-consuming device. While similar in structure, their operation depends on energy conversion direction. Both play vital roles in industrial systems, with generators providing electricity and motors driving mechanical equipment like pumps, fans, and compressors. 2. What is power factor and why is it important? Power factor is a ratio of real power, kilowatt, used to perform work to apparent power, kVA, supplied to the circuit. It indicates how efficiently electrical power is converted into useful work. A power factor of 1 or 100% is ideal, meaning all supplied power is used effectively. Low power factor results in energy losses, higher bills, and overloading of electrical components. Utilities often charge penalties for poor power factor. Improving it through capacitor banks or synchronous condensers can enhance efficiency, reduce costs, and prolong equipment life in industrial and commercial systems. 3. What is the difference between AC and DC? AC, alternating current, changes direction periodically, while DC, direct current, flows in one consistent direction. AC is used in homes and businesses due to ease of voltage transformation and long-distance transmission. It's typically sinusoidal in nature. DC, on the other hand, powers batteries, electronics, and devices requiring constant voltage. Each has unique advantages. AC is easier to generate and distribute, while DC offers better performance for sensitive electronic devices. Technologies like inverters and rectifiers are used to convert between AC and DC in various systems like solar panels and electric vehicles. 4. What is a transformer and how does it work? A transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. It consists of primary and secondary windings wrapped around a magnetic core. When AC flows through the primary winding, it creates a magnetic field, inducing voltage in the secondary winding. Transformers can step up or step down voltage levels depending on the turns ratio between the windings. They are crucial for power distribution, enabling efficient transmission over long distances by reducing losses and ensuring appropriate voltage levels for various applications. 5. What are the types of electrical faults? Electrical faults are abnormal conditions in power systems. Common types include a short circuit fault caused by low impedance path between conductors, an open circuit fault when a conductor breaks and interrupts current flow, a symmetrical fault, all phases are affected equally, rare but severe, or unsymmetrical faults, one or two phases affected, more common, a ground fault, occur when current flows to the ground unexpectedly. Detecting and isolating these faults promptly prevents equipment damage and ensures safety. Protective devices like circuit breakers, relays, and fuses play a key role in fault management. 6. What is the difference between a relay and a circuit breaker? A relay is a protective device that senses faults and sends a signal to trip the circuit breaker. It does not directly interrupt the circuit. A circuit breaker is a mechanical switching device that can open or close a circuit under normal or fault conditions, while a relay operates electronically or electromagnetically to monitor current, voltage, or frequency deviations. The circuit breaker physically isolates the faulty section. Together, they enhance protection in power systems. The relay detects, and the breaker acts. Their coordination ensures timely disconnection of faulted circuits to prevent equipment damage. 7. Explain Ohm's law. Ohm's law defines a relationship between voltage, V, current, I, and resistance, R, in an electrical circuit. It states, V equals I times R, where OV is voltage in volts, I is current in amperes. R is resistance in ohms. This fundamental principle helps in designing and analyzing electrical circuits. It enables calculation of any one quantity when the other two are known. Ohm's law applies to linear and resistive elements, but not to nonlinear components like diodes. It forms the basis for further laws and concepts in electrical engineering. 8. What is earthing and why is it important? Earthing, or grounding, connect electrical systems to the earth to ensure safety. It provides a path for fault current to flow safely into the ground, preventing electric shock or fire. It stabilizes voltage levels during lightning or fault conditions and protects equipment from damage. Types of earthing include plate, pipe, rod, and strip earthing. Proper earthing reduces the risk of electrical hazards, ensures the safe operation of equipment, and is mandatory in building codes and safety regulations. It is essential in residential, commercial, and industrial electrical installations. 9. What is the function of a capacitor in an electric circuit? A capacitor stores electrical energy in an electric field and releases it when required. It consists of two conductive plates separated by a dielectric material. In AC circuits, capacitors block DC while allowing AC to pass, helping in filtering, power factor correction, and signal coupling. In DC circuits, they smooth voltage fluctuations in power supplies. Capacitors are also used in timing applications, motor starting, and resonance circuits. Their ability to store and discharge energy rapidly makes them indispensable in both analog and digital electronics. 10. What is the difference between single-phase and three-phase power? Single-phase power uses one alternating voltage and is suitable for homes and small loads. It has a pulsating nature, which may cause fluctuation in power delivery. Three-phase power uses three alternating voltages, 120 degrees apart, providing constant power flow. It's more efficient for industrial and heavy load applications due to reduced conductor size and balanced load sharing. Three-phase systems also enable simpler motor designs and higher performance. Understanding the differences is crucial for selecting appropriate systems for residential, commercial, or industrial use. 11. What is an inductor and what is its role in a circuit? An inductor is a passive electrical component that stores energy in a magnetic field when current flows through it. It resists changes in current, making it useful in AC circuits for filtering, tuning, and energy storage. Inductors are commonly found in power supplies, transformers, motors, and radio frequency circuits. In conjunction with capacitors and resistors, they form LC and RLC circuits, which are essential in signal processing and power electronics. Inductors also help smooth out ripple currents in converters and stabilize current flow in electrical systems. 12. What is meant by harmonics in electrical systems? Harmonics are voltage or current waveforms with frequencies that are multiples of the fundamental frequency, typically 50 or 60 Hz. They distort the ideal sinusoidal wave, leading to equipment overheating, reduce efficiency, malfunctioning electronics, and increase losses. Common sources include nonlinear loads like variable frequency drives, VFDs, computers, and fluorescent lighting. Harmonics are analyzed using Fourier transform and mitigated using filters, transformers, or harmonic compensators. Understanding and controlling harmonics is vital for maintaining power quality and protecting sensitive equipment in industrial and commercial installations. 18. What are the different types of cables used in electrical systems? Electrical cables come in various types based on application, insulation, and voltage rating. Common types include OPVC insulated cables for domestic wiring, OXLPE cables for higher voltage and industrial use, armored cables for underground and heavy-duty use, coaxial cables for communication systems, fiber optic cables for high-speed data transmission. Cable selection depends on current carrying capacity, environmental conditions, and safety standards. Proper cable choice ensures durability, low losses, and fire safety in electrical installations. 14. What is a PLC and where is it used? A PLC, Programmable Logic Controller, is a digital computer used for automation of industrial processes. It monitors inputs, makes decisions based on program logic, and controls outputs of managed machines or processes. PLCs are used in manufacturing, power plants, transportation systems, and water treatment facilities. They offer flexibility, reliability, and ease of troubleshooting. Ladder logic is a common programming language for PLCs. Their modular design allows easy integration and expansion, making them essential in modern industrial control systems. 15. What is load factor in power systems? Load factor is a ratio of average load to the maximum load over a specific period. It's expressed as load factor equals average load times time / peak load times time. A high load factor indicates efficient usage of electrical power and stable load demand. Low load factor implies fluctuating usage, leading to poor efficiency and higher demand charges. Utilities and engineers monitor load factor to optimize generation, distribution, and billing. Improving load factor reduces costs and strain on the electrical infrastructure. 16. What is the function of a diode? A diode is a semiconductor device that allows current to flow in one direction only. It has two terminals, anode and cathode. Diodes are used in rectification, AC to DC conversion, voltage regulation, signal demodulation, and protection circuits. Types of diodes include Zener, Schottky, LED, and photodiodes. In power electronics, diodes prevent reverse current flow and protect sensitive components. Their unidirectional property makes them essential in electronic circuit design and protection applications. 17. What is a synchronous machine? A synchronous machine is an AC machine where the rotor rotates at the same speed as the stator's magnetic field. It operates either as a synchronous motor, converting electrical to mechanical energy, or a synchronous generator, doing the reverse. These machines are used in power generation, large industrial motors, and grid stabilization. They maintain constant speed under varying loads and improve power factor when overexcited. Synchronous machines are essential for high precision and stable power applications in electrical engineering. 18. Explain the difference between fuse and MCB. A fuse is a sacrificial device that melts to break the circuit during overcurrent, whereas an MCB, miniature circuit breaker, is a switch that trips open and can be reset. Fuses are faster in action and cheaper but must be replaced after tripping. MCBs offer convenience, better discrimination, and longer life. MCBs are used in domestic and industrial circuits for overload and short-circuit protection. While both prevent equipment damage and fire hazards, MCBs are now preferred for modern installations due to ease of operation and safety. 19. What is the purpose of a resistor? A resistor limits or controls the flow of electric current in a circuit. It converts electrical energy into heat and is defined by resistance in Ohm's ohm symbol. Resistors are used to divide voltages, set biasing conditions, limit current to LEDs, and form timing circuits with capacitors. They come in fixed and variable types. Material, tolerance, and power rating determine resistor suitability for specific applications. Understanding resistance and circuit behavior is key to effective electronic design and troubleshooting. 20. What is AVFD, variable frequency drive? AVFD controls the speed and torque of an AC motor by varying the frequency and voltage of its power supply. It enhances process control, reduces energy consumption, and minimizes mechanical stress on equipment. VFDs are widely used in pumps, fans, compressors, and conveyors. They also help with soft starting and stopping of motors. Modern VFDs include protections, diagnostics, and communication capabilities. They are critical components in industrial automation and energy-efficient systems. 21. What is the role of SCADA in electrical systems? SCADA, Supervisor Control and Data Acquisition, is a system used to monitor and control infrastructure and industrial processes. In electrical systems, it gathers real-time data, controls equipment remotely, and alerts operators to faults or inefficiencies. SCADA ensures reliability and efficiency in power generation, transmission, and distribution. Components include RTUS, PLCs, HMIS, and communication networks. With increasing demand for smart grids, SCADA plays a vital role in integrating renewable energy, improving grid reliability, and optimizing resource usage. 22. What is insulation resistance and how is it measured? Insulation resistance is the resistance offered by insulating materials to leakage current. It is measured using a megometer or mega. High insulation resistance indicates good insulation and minimal leakage, ensuring equipment safety and performance. It's measured between conductors and earth or between phases. Periodic testing of insulation resistance in cables, motors, and transformers is vital to detect deterioration and prevent breakdowns. Factors like temperature, moisture, and aging can affect insulation. Maintaining high insulation resistance reduces the risk of electric shock, fire, and equipment failure. 23. What is a short circuit and how is it different from overload? A short circuit occurs when 2 points at different potentials come into direct contact, causing a sudden surge of current. This can lead to overheating, fire, or equipment damage. Overload, however, is when current exceeds a circuit's rated capacity over time, stressing wires and components. Protective devices like fuses and breakers isolate circuits during both conditions. Understanding their differences is crucial in designing protection schemes and maintaining system reliability. Quick detection and isolation prevent escalation and ensure safety. 24. What is Kirchhoff's law? Kirchhoff's laws consist of two principles. Kirchhoff's current law, KCL, the total current entering a node equals the total current leaving it. Kirchhoff's voltage law, KVL, the sum of voltages around a closed loop equals zero. These laws help in analyzing complex electrical networks by applying them to nodes and loops. They are essential for circuit analysis, including mesh and nodal analysis. Mastery of Kirchhoff's laws is crucial for solving real-world engineering problems and designing reliable circuits. 25. What are surge protectors and how do they work? Surge protectors safeguard electrical devices from voltage spikes caused by lightning, switching surges, or faults. They divert excess voltage to the ground using components like metal oxide varistors, MOVs, or gas discharge tubes. This prevents damage to sensitive electronics like computers and appliances. Surge protection is critical in both residential and industrial settings to maintain uptime and protect investments. Installing surge protectors at distribution boards and outlets helps enhance electrical safety and equipment lifespan. Understanding these technical questions and answers prepares you for the practical challenges of electrical engineering interviews. Employers seek candidates with both theoretical knowledge and applied skills. Keep practicing, stay updated with modern technologies, and build confidence through mock interviews. With the right preparation, you'll excel in your electrical engineering career journey.